My dear students, in today's video I want to discuss how to represent a control system using block diagram technique. So let us start our today's topic, that is how to represent a control system using block diagram technique. So already I have discussed in my last lecture about the block diagram technique applied for control system, then about the feedback and the effect of feedback in control system engineering. So today's topic is how to represent a control system using block diagram reduction technique. So there is a procedure, we have to follow that procedure, then easily we can represent any control system using block diagram technique. So let us follow all the steps, and in simple way we can solve all types of control system using block diagram technique. So first point, find the differential equations to represent the systems. So already I have discussed in my previous lecture, that is each and every control system can be represented by differential equations, and so first step is to find the differential equations to represent the systems. The second step, take the Laplace transform for each equations, and here we should assume 0 initial condition. So this is the second step we have to follow. Then the third step, is draw the block diagram for each equations separately. And fourth step, that is combine combine all block diagrams to represent the overall block diagram of each overall block diagram of control system. So this is the steps to follow how to represent a control system using block diagram technique. And next step, apply branch current and node voltage rule, and also apply KVL for electrical circuit. So these are the steps to follow to solve electrical network to represent the block diagram technique. So let us first discuss, let us consider a RC circuit. So for RC circuit, how to represent this by the block diagram technique. So this is the circuit. This is an electrical network. Let us take, this is input voltage, this is the output voltage. So this is R, this is C, and let us assume that this current is I. So first we have to calculate the differential equation. Step 1, we have to calculate the differential equation to represent this electrical circuit in the block diagram technique in the control system. So let us find what is your this is current I. So I is equal to, by applying branch current method, so this voltage is VI, and this node voltage, this is the node voltage, and this step the ground. So V naught, then this is VI minus V naught by R, VI minus V naught by R. So taking Laplace of this, I of S is equal to Vi of S minus V naught of S by R. So now we can represent this differential equation by a block diagram technique. So This is the block diagram representation of this equation. Let us take this is Vi of s, then this is V naught of s, let's take negative feedback, and this is the block represent the resistance, that is 1 by R, and this is I naught I of s. So this branch current Is is represented by this flux, that is here VIS minus, this is Vi of s minus V naught of s divided by R is equal to I of s. This equation is satisfied. So now let us find the output voltage equation. So output voltage V naught of s is equal to, that is 1 by C dSn I dt. So taking Laplace of this, taking Laplace of this, that is V naught of s is equal to I of s by Cs. So taking zero initial condition, so V naught of s is this much. So now we can draw the block diagram for this, that is 1 by Cs, this is I of s, and this is V naught of s. So this is the block diagram representation of this differential equation. So now we can combine these two block diagram to find the overall block diagram representation of this system. So let us combine these two block diagram. Now we can combine these two block diagram. So you first draw this block diagram, then you draw one comparator circuit, then 1 by R, then 1 by Cs. Now you can, this is your minus, this is plus Pi of s. So draw another block diagram, that is 1 by C of s. This is your V naught of s. Therefore this is I of s. So now we have combined these two block diagram. Here Vi of s minus V naught of s by R, then which is equal to I of s. So I of s into 1 by Cs is equal to V naught of s. So both the block diagram is combined. So now we can find out what is the transfer function of this. So to find out the transfer function, V naught by V naught transfer function T of s is equal to V naught of s by Vi of s is equal to, that is output by input, which is equal to 1 by RCS divided by 1 plus 1 by RCS. It is a negative feedback, therefore 1 plus 1 by RCS. So we can take this common LCM, that is 1 by 1 plus RCS is the overall transfer function of this system. So now we can directly find the transfer function from the block diagram. Now we can check whether this is matching with this. If we can find out the transfer function from this diagram or from differential equation. So let us find out the transfer function from differential equation. So we have to calculate what is VI by applying Kirchhoff's voltage law here is equal to, that is I into R plus of 1 by C I dt, or taking the Laplace transform is equal to IFS into R plus IFS by CS. So now you can calculate what is V naught. V naught is equal to IFS by CS. So now directly we can calculate. Here we can take common IFS, then this will be R plus 1 by CS. So this is V naught of S. So now we can find out what is V naught of S by Vi of S, which is equal to I of S by CS divided by I of S into R plus 1 by CS. So I of S, this will be cancelled, then CS will be cancelled after taking LCM, therefore it is also 1 plus RCS is the transfer function. So same way we can find out the transfer function of the system, that is same from block diagram, and directly we can calculate from differential equation. Now let us take another example, that is RL circuit. For RL circuit, so this is the your VI is R, L, this is your V naught, and this is your I. So now same way we have to calculate the differential equation, that is the first step to find the branch current here, that is I is equal to this voltage, node voltage will be V naught. So this is Vi, that is Vi minus V naught divided by R. So taking Laplace transform, I of S is equal to Vi of S minus V naught of S divided by R. Now we can represent this by a block diagram, that is, so this is the block diagram, Vi of S, this is 1 by R I of S. So this is V naught of S minus, here is plus. So this is the block diagram representation of this differential equation. So now we can find out what is the output voltage V naught of V naught is equal to L di by dt, taking Laplace transform of this V naught of S Ls I of S. So now we can represent this. This is the block diagram representation. This is your Ls and this is I of S and this is V naught of S. Now if we will combine both this block diagram, then we can find the block diagram of entire system. So let us combine both the block diagram. So this is the V I of S. This is 1 by R. Ls this is V naught of S and this is I of S. This will be minus, this will be plus. So this is the block diagram representation of RL circuit. So if we can find out the transfer function T of S is equal to V naught of S by Vi of S is equal to Ls by R divided by 1 plus Ls by R. So if we will take LCM here, R plus Ls, then RR will be cancelled. So overall transfer function will be Ls by R plus Ls. This is the overall transfer function of RL circuit. Similarly, we can find out or represent the block diagram to RLC circuit. For RLC circuit, so for RLC circuit, this is your RLC circuit. This is VI RLC and this is the V naught. So here we can directly take Laplace transform here, that can be easily done. So again we have to draw this circuit. This is R Ls I of S Vi of S 1 by Cs. So V naught of S. So now first we can find out what is the branch current here. So I of S is equal to, here node voltage is V naught. So Vi of S minus V naught of S divided by R plus Ls. Similarly, we can find out the output voltage V naught of S is equal to I of S by Cs. So now we can draw the block diagram for this system easily, same way. So this is 1 by R plus Ls, and this is 1 by Cs, and this is the V naught of S, this is I of S, EI of S, and this is the minus, this is plus. So this is the block diagram representation of RLC series circuit. So this is very easy. So therefore we can similar way we can calculate the transfer function of this. So thank you very much. In my next lecture I will discuss how to solve the block diagram problems by block diagram reduction technique. Thank you very much.